Hey, how you doing? I'm Julian. I tried to figure out how to get this board working in Home Assistant or esphome, um, and more how to get those LED, LCD display letters to work. And I had to write an external component for that. And because I didn't find any good documentation online, and I had to get a lot of the documentation from the actual source code, I thought maybe some other people would be interested in how to create an external component and how to extend esphome with their own functionality. So I thought I wanted to share how I did it and how you can get started in creating your own external components. So let's get right into it. First of all, for everybody using this particular board, it's from AliExpress. It's called ES32A08, and I think this is the 24 volts version. I was trying to use it for a friend of mine in a small industrial application. Where we are going to build into the cabinet of the machine, which is 24 volt supply voltage. So it's very nice to use a board that's 24 volt compatible without any external power bricks or whatever. And this board also supplies the ESP32 on it with power, so we can just wire it into the cabinet and use all the I/O. I just gave you a quick rundown of the board itself. We have 8 relay outputs on the right side, which can switch any input voltage. They have their own common pins, so you can supply whatever voltage you want to switch with those. We have a set of digital inputs down below. Those are 24 volt digital inputs, which I wanted to use in my application. And we also have a set of analog inputs on the top for analog current inputs, 0 to 40 milliamps, and 4 0 to 10 volt voltage inputs analog, but we can only use 2 of the voltage inputs if we want to use the Wi-Fi on the ESP32. And I think most people will use the Wi-Fi on the chip. So yeah, it's 6 analog inputs in total. Also on the, let me have a look, up here. Also on the left side of the device, we have an RS485 connection where we can use Modbus devices or whatever talks over RS485 buses. So a very versatile little board. You can see it in the background, 20 euros. So I don't think it's about 20 somewhat US dollars. And yeah, it's a very capable device. It's funny everything. It's very funnily about interconnection. We also have 4 push buttons on the bottom, together with the 4-digit 7-segment display. So yeah, it's a capable device. If you get the board, there are a couple different boards, smaller boards without relay outputs. There's a 12 volts version. There's the version with and without the DIN rail cases. I got the one with the case because I can just clip it to the cabinet and everything's gonna be fine. So yeah, I think it's a very capable device, but there was absolutely zero documentation online. From a Reddit post, I got the datasheet, which was very convenient because that's basically all you need, and that's this one. So here we can see all the components, all their interconnections. Here we have the ESP32, They also use the dev kit CV4. I have the AZ delivery dev kit for the ESP32. It's an older dev kit, but works perfectly fine with a socket. We have a socket with two different for two different sizes of ESP or for baseboards. The dev kit works perfectly fine, and yeah. In order to flash it and flash the board, you have to take it out of the socket because some of the pins used for the serial interface are also accessible for the board and are pulled to some voltages that hold it from being able to be flashed when it's inside the socket. But once you have it flashed with ESP Home, you can just flash it over OTA, over Wi-Fi, and you're gonna be all right. So yeah, let's get into it. The display is funny in that way that it doesn't use a driver. The display is directly connected or indirectly connected to the ESP32, and there's no driver IC for the display, like the, for example, MAX 7219, which is a driver for the same display, but is an SPI-based driver. And yeah, I wanted to use the display with the board, or I just wanted to make everything on the board accessible via ESP Home. So I started to write my own Lambda to use C++ to talk to the device, and it works, but it's not very nice. So I thought, let's get started with creating an external component that I also want to publish to the ESP Home repo later, so it's accessible for everybody. So yeah, I also started with the MAX 7219 component as my base layout, so to have something to work off, so I don't have to write everything myself, and because it also runs the same display, it shares a lot of the data and a lot of the functionality I actually need. So yeah, first of all, I would like to show you which kind of interface I would like to expose for ESP Home to be able to use the component. In the end, I would like to be able to have a display component that uses a 7-segment platform with a arbitrary ID, with a Lambda that is known for other display components where you can just print stuff in a Lambda. You would also have to put it like that, I think. The 7-segment display, like we saw in the schematic before, has... where is it? There it is. Has A, B, C, D, E, F, G, and I think it's called decimal point, DP. It has those segments, and we want to address all the segments independently. So we will have a pin for the A, B, C, D, E, F, G, and the decimal point pin. Also, because we cannot access every digit on its own, we have to we cannot address every digit at the same time. We will have to have pins to select the digit we want to display at currently, a little bit like a pointer to the current segment. And these pins also specify the number of digits we have in total. For example, if we have a look at the schematic again, here we have 4 digits because this display module has 4 digits on its own, and we can see we have a G1, G2, G3, and G4 pin, and those pins basically say to the display if the pin G1 is high and I set the E and D segments, then the E and D segments will be lit up on the first digit. If I enable the G2 pin and disable all other G pins, and I say E and D, the segments E and D on the second display will be enabled. Also, if I enable G1, G2, G3, and G4, or any other combination of multiple of those digit pins, all inputs I write will illuminate all the segments of the selected display. So for example, if I had G1 and G2, and I would write the A and F segment high, I would have the A and F segments of the first two digits illuminated. So that's a little bit tricky because we cannot write a whole string to the entire display. We have to walk byte by byte or character by character through the display and write the digit we want to write. And in order to refresh the whole display, we have to do this multiple times per second, so all the digits light up at the same time. A little bit like a CRT scanning monitor, whatever. And this brings a couple of changes, or a couple of not changes, but a couple of complications with it, like ghosting. We have to turn off all the other segments before and leave them on afterwards, so it's illuminated bright enough so it will stay on for long enough and stuff like that. But we will get to that in the next segment, so to call. But first of all, I wanted to go into a little bit more detail why it's a little more complicated to talk to this display on this particular board. And that is because the pins are not exactly or not directly exposed from the microcontroller, but we use multiplexing chips in order to multiplex the outputs of the microcontroller, because obviously we don't have enough outputs or inputs from the microcontroller to see all those devices. So yeah, we can see we have the the A through DAP pins and the G1 to through G4 pins, which are connected to, where is it? Here, to a 74HC595D multiplexer, and not just one, but actually two or three of them. One of the multiplexers is connected to the digital outputs of the relays, and two of the multiplexers are connected to the digital tube display. We also have 4 pins which are not connected to anything of the second multiplexer, but we can't use those. So yeah, first of all we would have to use those multiplexers in esphome, and then set those pins the multiplexers expose to the pins we want to use as inputs for the digital display. But that is nothing to do with the external component itself, and we will get started on building the external component now. So first of all, like I said, this is the interface I would like to expose for the API for esphome, so we can control the single pins. First of all, we would go to GitHub and go to the esphome repo, which is just github/esphome. Choose the esphome repo itself, and I would fork the repo if you want to contribute it back to the repository later, or you can just clone it in order to build your own components and then expose them for your own use without making them accessible for other, or without contributing back to the esphome repository. I forked the repo for my own component, but in order to show you how to do it, I will just pull the code for my own use. Or no, I will actually fork it, so I have it on my own GitHub, so we can expose it publicly later. So yeah, I have already forked the repo, so I guess I will have to make. Okay, I could also make another branch. Oh, I will just pull it. Okay, so let's go into the. You can see I already have some repos or some folders with tests and stuff. So just go into your folder you want to create, git clone, I'll just call it YouTube. And if that is done, we can open it in Visual Studio Code for my example. Obviously, you can use whatever editor you like. I use Visual Studio Code. I also use Copilot because I'm not that good in C++. And having some form of autocomplete is very nice. Sometimes it will autocomplete all the wrong things, but you will have to be able to differentiate what will work and what won't, or sometimes you will have to troubleshoot later. But having something that makes suggestions what you could try is very, very convenient. So we get Visual Studio Code to set up everything. The build in the backend of esphome is based on Platform.io, like we see down here. You can also use Platform.io on your own for other projects, but we will wait till it's finished installing everything, and then I'll be back. So, Platform.io has successfully installed all the libraries it needed, and we can get started on creating our component. In order to use the component or to build stuff, we can use the dev container inside here, or we can use the setup script in the scripts folder, which is bash based, so this will only work on Linux. I also have a setup script for Windows as a batch script, so if you're interested in that, I can put that in the video description. But I think we will use the dev container. So yeah. So okay, I think we won't use Docker. I'm a little bit on what to use because I already have my local environment set up and I just copied this environment. It's a mess, but I will use my personal setup file. I will just drag it over to the script. Maybe I will also push it to the main branch if they want to have a setup script for Windows. But basically, what this does is it will create a virtual environment, install all the required Python tools, and set up everything for you. So in order to run it, we can just go to the terminal, go /script setup.bat and get it. And get it to set up everything. Takes a moment, but it will grab all the packages from pip. And then we will be able to develop C++ code and the responding Python code shortly. In the meanwhile, we can go back to the esphome and can have a look at the external component page, which shows you how to use it, how to implement it, so you can reference components from it. But as you can see, we can just, or the most important thing in here is the setup or the directory structure we need in order to make esphome recognize the components. So we need a top folder with the name of the component, or let's have this one. We need a main folder with the main name of the component, like I will call it 7 segment. We need an init.py, a component C++, component header, and whatever it exposes .py. So we will need a display.py because we want to expose a display API, and this file is called when esphome sets up the component and compiles it. So yeah, everything else I think is really not that obvious. So I had to do a lot of digging in the source code to be able to find out how everything actually works. So I hope I can give everybody a little bit of a heads up so you don't have to do it yourself. So in order to get started, we will go into the esphome directory, into the components, and here's all the components listed that are available right now. There's some basic components, like I think here's a GPIO component. Yeah, there it is. GPIO binary, one-wire output, whatever. Those are extended GPIO components, but there are also the core libraries, and all the core libraries you can reference inside your own component in order to use esphome build functionality and expose them to your component. Everything inside the components folder you cannot use inside your own component, or not directly. I tried a little bit of that, I didn't get it to work, but I would advise you to only use core components if you want to extend your own functionality. So we will go into the components folder, we will look for the max7219 file, where it is, max7219, there it is. This is the folder containing everything we need. I will just copy it, paste it in the same directory again, and we can get started on renaming it to our 7seg for 7 segment. And I will also go ahead and rename all the components or the files inside to 7seg. Like I said, the display.py is can stay like display.py because it's the functionality we want to expose. We want to expose the display component. The init.py is the component, or is the file that would be run if we would have a driver like an SPI driver, for example, a driver we want to set up and expose for other APIs to use. So if we have a declaration like, for example, SPI double dot SPI, and we have some, I don't know, yeah, for example, something like that. And we want to set up this one, and later on we want to use the SPI functionality as a bus interface for other components. Stuff like that would be set up in the init.py. But we only have the display component, and this is in the frame of reference for every component we build. So yeah, we don't need an init.py, so we will leave that blank because the file has to be there, I think. But we will just leave it here and empty. The display.py is the main component esphome uses, or the exponent, the component you want to expose. .py is the file esphome uses for the code generation and code validation, or the config validation. So we see we have esphome code gen is code generation, CG, and esphome config validation, CV. And it does exactly what it says. First of all, if we have components in the YAML file for esphome that we want to validate, like is it we know we want to have a GPIO pin as an input for the component, then we use the config validation to set it up in the way that if the user specifies any other pin, or a pin that isn't able to be used as a GPIO output, for example, that the config itself will have a red underline and will say you can't use this pin. This makes it very easy for the user to only specify correct values, and also to guide the user in using it and stuff like that. Also, it enables us, the developer, to specify the component in a way that we know that all the APIs we want to use in the component are accessible to us. So in order for the max 7219 component, we see that it declares a base component. That's what every component will do. It configures a number of chips, a default for that, an intensity, also a default value for that, and a reverse enable, which is a flag, and sets the default to false. And here we can see it also uses a display component as the base and extends its functionality. So all the display component inputs we can give it, like I don't know actually what all the display inputs are, but the basic display functionality is set up for us already, and all the other functionality we want to expose we can add on with the extend inside the extend fields here. So the user extended it with the number of chips, the conf intensity, and the reverse enable flag. Also, the display scheme or the display component is extended as a polling component and an SPI device. This also adds on the functionality of a polling component. A polling component is a component that updates in a set time interval we can specify, like here 1 second. And the SPI device scheme is just says us it's an SPI device. It's based on SPI functionality. And this also tells esphome that we will have to give it an SPI device in order to be able to function. So we cannot use this component without an SPI device, and we have specified it here. Also, the to-code is the part that esphome runs when it's generating the code, and in here we set it in order for we add the config ID variable, which I think it's something like a base component or a variable we need for the basic functionality. To be honest, I don't understand everything fully, like you may be able to see from the way I'm stumbling right here. But I think I understand enough for you to be able to go based on a little bit of pre-knowledge from me. So it also sets up the SPI device with all our config and our variables. It will display. It will set up the display device, and here is the part that's most interesting. There's codegen add the variable set number of chips and give that function this input. And we will see this referenced back in the C++ code later, because this is the part of the code generation when esphome compiles your YAML file to actual C++ code, where it passes your config data into the C++ code. So this is the the API for that, for example. Also, we have the lambda defined in here, which is the way we specify that the user is able to access the component in the lambda with the it.keyword. It's like in other display components, you have it.print. If we go back to the, I think if we go to the max 7219, for example, in here, you can see that, here it is, it.print, and it is the component, or it is the, not the component, it's the C object we want to expose to be able to base our API on. So we said that it is to be named it in the code. It has a non-return, it's a void return value, so it doesn't give anything back. And we add a writer to the lambda, that is our interface that pushes data from the lambda function to our component and vice versa. Or I think not vice versa, because we have the non-return. But this is the interface we want to specify in the Python code. Now we will go over to the C++ header file in order for you to be able to understand what this exposes. We have the core component included up top. We use some time functionality, so we have the time included. We have the SPI headers included to be able to use SPI functionality. And we are inside the ESP home namespace, which is the general namespace for the apps. And we specify the namespace of our own component, so we don't have any name clashing and other stuff. We specify our class, the main class of the component, and this is the writer functionality, which we specify in order to be able to pass data from the YAML file, from the Lambda, to our component. The max component or the top component is extended with some other component and functionality. Here we extend it with the polling and the SPI device components. This is something we could already see in the display.py here. Right here, yeah. Then we have the set writer. This is a function we call, like I said, this is the interface. This is the code we actually want to call when this function is called. var.setWriter in C++ calls the setWriter functionality inside here. Also, set intensity, set numchips, set reverse are also called from set numchips, set intensity, and set reverse. And pass in the values we specified up here. So if we don't specify any value, it will pass the default value of false in this point, or these numbers, whatever. And also we have specified a min-max range in here, and we have also specified that the input to the reverse enable can just be a boolean. Yes, no, true, false, enable, disable, 1 or 0. Can also be. Yeah, so the header file, if you don't know C++ at all, just a quick recap. The header file just exposes the functions, or just gives a template of what functions we have, what data we have, and if they are publicly available, non-publicly available, and what kind of data those functions return and want to have as an input. So the setWriter method wants to have a setWriter type. The setup method will be overridden by the compiler, and those other methods the compiler will override in its code generation with our own methods. Then we have the print, print functions and their overloads. So in order to be able to print a character with an offset, like you want to print a 1, but not in the first, but in the second display or the second segment, you could specify an offset like pos1, and then the characters from then on. For example, yeah, overloading in C++ is just you specify the same method with different kinds of input data, and you will specify how to handle it in the actual C++ code, so that the compiler knows if I call this function with inputs of those types, what underlying function to call. So yeah, we also have string format time and stuff like this. It's basic print functionality and printf functionality in order to be able to use standard print. Protected functions are those not accessible from the outside. So send byte and send to all, for example, are functions that are declared in the C++ code, but shouldn't be able to be accessed from anybody else but the code itself. So those are no functions the user could call by saying it.sendByte and specifying registers. As far as I'm aware, this is the way this works. I'm not 100% sure. Also, we declare variables under here. We don't use public variables in order to set some stuff. We could use public variables for, I don't know, anything, but we will use them protected, so they are just accessible from the code itself. We have the intensity change, number of chips, a buffer to store the characters, the reverse flag, and the max writer, which is an optional. Yeah, that's it. And then we will go into the C++ code. I won't take too long in here because this is the actual implementation, and the implementation obviously depends very heavily on what you want to do. The most important stuff is really the Python file to set up the component and the header file to receive, to build the interface between the component, or between the code generation and the C++ component itself. Obviously, you have to satisfy all the stuff you set in the header file in order for this to be able to compile. But if you have everything set up, everything else will work on its own, more or less. So inside the actual C++ code, when we have a look at it, I will just collapse those. We'll see it says it can't include the header file, obviously, because we have called the header file 7sec.h. And if you go in here and we call this 7sec, then we can see it can now include the header file. Yeah, so the header file specified namespaces, we use those namespaces. We use static constants in here for some variables we want to use. The author of the component had some registers hard-coded in here, had some values for unknown characters hard-coded in here. One thing I also use for my component is the ASCII to RAW mapping he used in order to display the segments and what character they will display as. So I have a easier time mapping ASCII to the actual lines. And it's very nice to be able to just reuse code or reuse this, what he did. Also, we have the get setup priority function, which just returns the setup priority. I really don't know what this actually does, but it seems to be needed for the component. So I basically just copy paste it in here, and I'm ready to go. The setup is called once the code runs to set up the component, and from then on is only called. I think it's never called again. It's just called in the setup stages. Also, don't wonder if you have an ESP log config, or the ESP log is just the functionality to be able to write to the log output. If you compile and upload via ESP home, also wirelessly, and you start the component, you will not see logging information from the setup. I think that's because the setup actually runs before the startup of the Wi-Fi. So the setup is already run when the Wi-Fi and the API start up, so it won't write anything to the log. The first thing you will see in the output log is the dump config. And this is a functionality the component exposes normally, which is just to, when everything is set up, like the Wi-Fi and stuff, for every component to dump the configuration. And this just shows you it's a max 7219. It has this number of chips, this intensity is set, this pin is set. So it will just show you basic information about the component and how it's set up. Yeah. Then we have the display functionality, which is something the author of the library just used for himself. And this is just the way he writes everything to the display. This is not a function that gets called from the outside. The only functions in here that get called from the outside is the update function. And as you can see in here, there's a very, very important code snippet. If you take anything from me, then it's that this code snippet is so important. I banged my head against the wall for the last 2 days because I didn't understand what it does. I still don't fully understand what it does, but nothing in terms of calling your component from a lambda will work if you don't do this. And that is this part of the code, or more exactly this one. If this writer has a value, then this writer is updated with a new pointer to itself. I really don't know what this means. I just know that APIs like it.print or the dot whatever you want to expose for your component to be used inside a Lambda function will not run if you don't have this. So the context of the app, I think, will not update correctly or at all if you don't have this. So yeah, this is what I didn't have because I didn't understand it. I thought it was implementation detail for this specific component. No, it's needed for every component that interacts with Lambda functionality, I think. So the author uses this in order to update some stuff, get his new context, and then execute the display functionality up top here. Also, we have the implementation of the different kinds of print functions, which he did very intelligently, I think, because he just implemented the basic print with a start position, and every other print functionality just piggybacks onto that and specifies an offset of 0 or some stuff. Yeah, I think it's the basic way how you would do it, and it's obviously don't rewrite code if you can just reuse it, and in this case it's very easy to reuse all the print functionality. I think he did very much this, no, not with the printf. Yeah, but I will, like I said, I won't go into too much detail of his implementation details in here. It was just to be able to set you up with a basic knowledge of like how those files in here inside the component are interconnected. So I think now I will just start to rewrite the component in a way I did it to show what you will have to change to make it your own. And it will take some time. So I think if that's all the information you needed, you can just quit the video right here and maybe understand a little more what you need. For everybody else who's a little more interested in how to actually start writing your own component, you can stay and have a look at me rambling in poor English and code some stuff up I have on the secondary screen. I will copy paste some parts because I obviously don't want to rewrite everything from scratch, but I think I will rewrite the most important parts so you know which parts to change and how the connections between them are. So I will start in the display.py, which is the main entry point for the code gen. First of all, we don't depend on SPI. We don't need an SPI bus. So we will just get rid of the SPI. Our namespace is going to be called 7sec. The component or the namespace name itself will also be 7sec. And we can basically do a find and replace on the max 289 here. And just go, we have to be aware of the case because we don't want to overwrite everything else. Okay, it was just the one place. So now we can overwrite this one. I just go uppercase 7sec. like this, and overwrite everything. So now we have just renamed it to our own component. Obviously, that's the first step you want to do. Maybe after removing everything unneeded, but I just did with find and replace, and it's very easy. Right here, we would specify the variables we want to make accessible to the user. Like, for example, I will just copy and paste this from my config. The author of this library has a reverse enable in his YAML, so this would be the place where you would go something like this in the YAML. So yeah, we don't need that. We will just go in here and use our pins. I had it hard-coded to use G1, G2, G3 and G4 pins. We'll get rid of that because we will not use these. We will use an array of pins, so we also will have a variable length of digits. So if you would have two of those segments hooked behind each other, you can just specify 8 segments and their according pins, and the library would just use them. Our config scheme is going to stay the same. It's not going to stay the same, but the naming of it will stay the same. We will also have to import another library. We will from esphome esphome.gp. I really don't know. If you don't know what you want to have in here for the maybe parameters. For example, I want to make the user only be able to specify GPIO output pins. So we need hardware, so we need a GPIO output, and it's only gonna be a GPIO output. We can't use GPIO inputs, obviously, to set the segments. So if we're interested in how to find what kind of CV dot whatever we would have to use in here, we can use the esphome folder and have a look in here. And we see there is they use esphome.codegen, SCG. I will just have to have a look which one I used. I think there is a pins in here. And inside the pins, there is a pin scheme registry and a schema creator, and there is different GPIO pin schemes. And we basically want to use the GPIO output pin scheme, and this is inside the pins, esphome pins.py. So esphome.pins import digital output pin schema. So we will be able to CV dot, this is not optional. We do have to specify those pins. So this is a CV require, and then we will give it a conf A. This is not right, but we will do CV dot schema. I think it's CV schema. Let me have a look. CV.ensure schema. So this is the way to validate that this is a valid output pin. And we will just go through this and expand it to all the outputs we need, like this. Like this. I called it. I called it differently. And all, as you can see, I also did a rookie mistake of trusting Copilot, because it said digital output pin schema. but we want to have a GPIO output pin schema. So yeah, this is fine like that. Also, we don't need the SPI device in here. And because we have to refresh the screen faster, we will do 25 milliseconds for the refreshing of the screen. From here on, we also don't need the SPI component registered. We don't need all of that. And because we don't need all of that, we can also not import them from up here. It's important to know that something like conf lambda, conf ID, and the chips number we had right before, those are in the esphome const. And if we go have a look in here, those are configuration options that esphome itself exposes, which have their own names. I would prefer to use pins or namings from here because they are given between, they are constant and they are provided by esphome, so they are generally the same between different components that use the same kind of functionality. Like if you would have something that uses active, whatever, you just use conf active from the constants and expose it that way. So it's basically the same API. Also, if esphome ever decided to change their naming scheme, whatever, everything that's inside the const will change with it, so you won't have to update your component in that way. So yeah, this is basically everything we would have to do for this. Also, in here we have the digits. Like I said before, we want to have the digits as a list of digits, so we can specify the amount or the number of digits we want to use later. And there we can just use cv ensure list. This ensures that it's a list, and we want to have it as a list of GPIO output pins again. So once you get it, I think it's very easy to just understand how this scheming works. So from there on, we will go down here, 7sec, and we will... okay, yeah, we still need to set up the different the data for those pins, or we have to pass it over to the C++. So I will also copy paste one before so we can have a look at it, and then I will just copy paste the rest. So I have a variable called pin A, and this pin A is the GPIO pin expression of my configuration, where the configuration is a.pin. So it basically just reads the a underscore pin from the YAML file, writes it into this, and then calls the C++ function that adds the data via the setAPin function. So, like I said, this will load it from the YAML file and write it in the C++ file. And we will do this for all of our other pins, like this. Now there's an interesting part for the digits, because the digits can be variable length, so we can't hard code this, but we can specify an array of digits, empty array at first, and we can just loop over the digits we have provided in the YAML file and extend the array. And once we have all the pins collected, we can just add it with the digits, so we can pass the array into C++ and make C++ take data from the array. How we do this on the C++ side later, we will see in the next step. Also, the conf lambda, we will just leave it as it is, because this just exposes all our functionality later to the lambda functions in order to be able to call our own C++ code from within lambda functionality. So let's get over to the header file and have a look at what we need to change in here. Obviously, we will have to do everything the same in order to rename everything. So we will rename this with a 7 sec in here. Replace all, and we will replace this with also 7 sec. Replace everything. So yeah, it's set up correctly like this. And from here on, the setWriter method will remain the same. Setup, dump config, update, get set up priority. Those are the functionalities we want to be able to expose for a display component always. I don't really know if it's just for a display component. I could be wrong. I don't really know. The display function we could call from within here, but we really just need the update function. Set intensity, set number of chips, set reverse. We don't need those. We will need our set pin methods. Set the A pin, set the B pin, like before. Like I said, these are the exact functions the Python code will call. And now to the interesting or more interesting parts. How can we set the number of digits? We have to use standard C++ vector with the GPIO pin type to pass it to the digits which also have to be defined down below. So yeah, I will get to that shortly. Also, those functions we don't need. All of these we don't need. I'll just copy paste in my code, and you see we have the GPIO pin functionality. I will initialize them to a null pointer, and in the setup I will check if they are not a null pointer. I don't know if this is the preferred way to set them up, but I do it in this way. So I would catch if maybe my config validation wouldn't be right, or I would have one pin not specified, whatever. At least in the setup in the C++, I would catch if one of the pins is set up to be a null pointer, and I could stop the component at that point and wouldn't have any null pointer dereferencing, anything like that. So yeah, this is how I created it. Also the 7 segment, I called it 7 segment. We will call it 7 sec writer. Yes, so this is all the functionality exposed. As you can see, here are the little dots below. They just show function definition is not found. That just means in the C++ code we haven't set up the functionality we want to use in the end. So yeah, now we have our basic interface set up in the header file, exposed the functionalities we want to expose. I will just make sure to have everything I really exposed set up in here. Okay, I had also a write digit method in there, but we won't need that. That was just for debugging purposes for me. So yeah, like I said, we have everything set up in the header. In order to be able to specify the interface we want to use, or the type of pin or the type of input we want to give to the setPin method, those are types of the core components. And this is where I had problems in the beginning as well, because if we go to the components, I wanted to reference a GPIO digital output, I think, in order to be specific about the output I want to use, but I can't use components in here, or component classes in here. We can just use core component or core classes. So if you would like to maybe use a GPIO input pin, we could, I see, I also haven't specified. Ah, okay. Because we have the core component header exposed, I think we have access to all the core component. Let's have a look in here. I don't know why it sees the GPIO pin as a valid input right here, actually, because normally I think we would have to include the esphome not components. Like I said, Copilot can be a little bit of a burden sometimes. We want to have the core component, the core GPIO header in here in order to be able to specify the GPIO pin, because, like I said, this is inside the core, inside the GPIO. Here we have the namespace GPIO, so this is what we import, and from there we can use a GPIO pin. And also I see I used an ordinary GPIO pin and not a GPIO input pin. That's very interesting. Ah, yes, because its pin mode is specified later on. And I think I also set the pin mode later on. So yeah, we have a little bit of a disparity here, because in the config validation we just allow input pins, but in the C++ we could also specify just a raw pin, or we will specify a raw pin, and this pin could be input or output, but the pin has to be able to be set to input or output via the GPIO pin definition. So in the C++ we will later set it to an output specifically, and if a component wouldn't be able to be set as an output, I think we would have an error way before this. But like I said, I'm not 100% sure on everything. This is just what I used, or what I did to be able to get my stuff working. Because I think there isn't a GPIO output pin to be specified. Yes, so like I said, this is the header setup. Now we'll go into the C++. All of this we just don't need. We will do the same spiel as before, with replacing this with a 7 seg, replace all, and this also this. So we have more namespacing fixed. The tag we see here is something that is specified in all the log functionality. If we go to a reference of the tag, for example, I really had hoped this would be faster. Okay, can go just into the setup. There is a reference to the tag. This just means that in the setup in the logging, you will see the name of your component and then the log output data after it. So in order to be able to specify the outputs, or to differentiate the log and outputs between the different components that produce that log output. So yeah, it's basically easier to set it as a static constant, obviously. We will have a second 7 segment unknown char. He differentiated, or he set it as all ones, so that makes all of the segments light up. I actually don't use it that way. I set my unknown characters to be 2, 3, 4, 5, 6, 7, 8 to be all 0. So if the user specifies some character that isn't be able to be rendered, or if we have an ASCII character like a new line or a line break, whatever, it just renders nothing. So we can just ignore those And I think that's a little bit more user-friendly. So if, for example, the user has an input that is anything by accident that isn't be able to render, then we just don't want to light up the whole display. Just render nothing. It's easier. It's not that much pain on the eyes. So yeah, I set everything we want to use for that as all 0. Also, he used just the upper 59 range of ASCII characters, starting at hex 20, losing all the bottom non-printable ASCII characters. The way I did it myself, I just extended his list basically by also using the non-printable characters, but setting them to the non-printer to the default 0 characters. So like you can see here, we have 128 ASCII characters, and we have a mapping for every character. That makes it very easy for us to just get the character, get the ASCII code of the character, and then just use the ASCII code inside the array. Otherwise, we would have to get the ASCII code, offset the ASCII code by the non-printable character, and then get the index of the array. Now we can just index into the array. We don't have to check if it's a printable character or not. We can just get index into the array and get the character we want. Or just display nothing if it's a non-printable character. So yeah, that's everything I did in order to map this. The get setup priority just is the same. My setup functionality does a little bit more. I will copy paste this in here. Like I said, for me this is not really about teaching you how to build the 7-segment display driver, but more of how you would use how you would build your own, and how the connections between the different components and files are, and what does what, in order to be able to understand it a little bit more. So yeah, we have a setup functionality exposed, which is exposed on the 7seg component. Did I call it wrong? No, I imported the right header. Why? Okay. I didn't close it. That's not it. What did I do wrong? What did I? No. I don't know what I did do wrong, but we also have to put I just put my getters in between here, and this is the functionality to expose the setup functionality, or the actual implementation. You could put this implementation right inside the header file. C++ allows you to do that. But I like to have the functionality decoupled from the header file. So yeah, everything it does is just, if it gets a set A pin with the GPIO pin pointer as the input, it will just set its own A underscore pin to the specified A pin. And yeah, we just do that. All the same for all the others. Also digits, it's just a vector of GPIO pin. So we can basically just set everything right here. Why does the global, did I not, isn't this, it's inside this namespace. Did I do anything wrong with the namespaces? 7seg. 7 sec. Like I said, you can see I'm really not the C++, the C++ pro dev, whatever. I just did a little bit of Arduino C++, if you can call it, if you even can call it that. And yeah, I do a lot of copy paste. Yeah. So e.pin digital write e_pin. Did I not specify the pins correctly? Ah, there we go. So yeah, the writer is the thing we have not exposed in the header file. Set writer 7 sec. We have. It's a 7 sec writer. So yeah, here we set all our variables. The setup, like I said, is the thing we want to call in the beginning. For every pin, I set the pin mode to GPIO output. I run the setup of the pin and then I turn off the pin. So in order to be able to just be sure that the pin is set up correctly, that the output mode of the pin is set up correctly and the pin is off, I just do this in my setup. All the same for the number of for all my digit pins, just in a loop. Also, I have a counter in here in order to be able to count the number of digits I have, and the screen buffer or the buffer of input values I use, I set to the size of the number of digits I have. So if I have 4 digits, I have a buffer of the size 4, so I can store 4 string variables or a string of the length of 4. This isn't completely correct at the moment because we can use the display the decimal point. So we could have a 12.44, for example. So we would have we would need a buffer of 5. But at the moment, this is just the basic implementation. I will just I would write a 1, 2, just the dot, no space, no number in the segment itself, and then the next number. I have the code somewhat working for pushing all the things together and printing multiple decimal points or all the segments as decimal points and stuff like that. But it's not bug-free at the moment, so I will just do the basic implementation for now. Also, for debugging purposes, I had my buffer pre-filled with the high or nothing, H, I, nothing, just to have any output. We will remove that because we could, in theory, also have a 1 digit. So this is not safe to do this way. I also set myself a setup complete variable, and yeah, so I know that the setup has completed successfully. I used this for debugging, but I will just leave it in here. So yeah, I will do a little break for now. I will go grab a new coffee and we'll be back shortly and we will go through the rest of it. So, back again, coffee in hand, we can go on. So, I was thinking, when I made my coffee, I was thinking and I thought, you know what, I'm just gonna copy paste all the rest in. We can fly over or gloss over the code When we have it, we will have to remove some small imperfections, but let me have a look real quick. I think it's easier for everybody if we don't expand this too long. So setup, display, dump config. So we will just go in here, put everything else in here. Obviously, we do have to replace all of this. We can remove this. And the right digit functionality. We can set this. Yeah, cool. I think, do I have it referenced anywhere? I don't think so. So we can just remove that. So yeah, this is done. This is done, and in here, config, blah blah. What are we missing in here? Let's have a look. Why don't I see what is wrong? Ah, this one. Not? The copy-paste kit. So 7 seg dot component. It's 7 seg component. Still not right. Damn. Some people screaming at their screen right now because they know what I did wrong. I currently don't. I currently don't. Declare ID. Ah, I still really don't know what I did do wrong before, but it was probably because anything in here or something in there. So yeah, right now we just got done editing all our files. I will get a git status on this one, and we see, yep, we have added a setup batch, and we have the component. Git add all. We will add everything. Git commit. This is also a very interesting part. The linter and stuff like this and the formatter runs with pre-commit hooks. So if you commit it, it will say failed and it will reformat some of the files. It won't remove stuff. It will just remove, it will remove something like white space, lines, whatever, but it won't remove anything important. And if you just rerun it, we will see it still failed. Why did it fail? Git status. Because it reformatted the files. I think we will just recommit like this. AM means just add changed files. And now we can see it failed because of the don't commit to branch. Don't commit to no commit branch. That means you're not supposed to commit back to the master branch. You're supposed to create your own branch to commit to. Actually, I don't know how to create git branch right now. Okay, like this. We can check out and use a new branch at the same time. So we will create a branch like commit to, and now we can commit all the changes to this branch. And now everything worked. Now we can push our changes. No, we can't, because this is a local repo. But in order for us to be able to use it, we will have to make it a public repository, so esphome can later pull the component. So I will just call the repository YouTube test. I will delete the data, but if you want to, you can have a look at my GitHub. I will link it down below as well. So if you want to, you can check out some of my stuff. Nothing completed, nothing interested in, nothing interesting in there. Yeah. So here we also see the git command to push an existing repository. We will just copy paste this in here. We can just paste all the lines like this. Why? Okay, so I have to set the, I haven't used Git in not such a long time, but I'm such a copy-paste kid in Git. It's not even funny anymore. Git branch u.origin. The branch main might be wrong. It could be master if I'm not surely mistaken. Like this. Why is it trying to push to the... So the origin exists. You wanna we will go to the yeah. So this happens when you just copy paste code and don't look at the output, because the first time I copy pasted it, oh no, it didn't even say. I don't know why. I had to push the. I had to add remove the remote origin for some reason. I really don't know. Normally I would say just fork it, create a new branch, work on the branch, then commit to the branch, to your repository to the branch. And if you want to merge it, just put a pull request in on ESP Home. But we won't go into how you would publish your stuff to ESP Home, because this also includes documentation and stuff, so it's a little more involved. Okay, so we can now check out commit to. We need to specify git. Maybe it is just. Is this the current? It's maybe. Yeah, it set the current branch to master, I think. So if we will reload the repository, we can see we only have one branch. And in here we can have a look at ESP Home, add the components, and inside the components we will have 7 sec. There it is. There we have our code. So everything is in here, created custom 7 segment driver. Perfect. So now everything's done so far. Now we can start using the component within ESP Home. So I will switch over to my local ESP Home instance, and we will have a look at how to integrate it. So this is my ESP Home. I will just scroll past the. So here it is. I have an external component specified. This is my current component. We will substitute this with our new GitHub repository. And this is in here. So we will just take the link, go back to our ESP Home instance, paste it in here. This will specify, what do we have here? The location, blah, 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 type git. I don't know why it's, the reference just means the branch. And because we pushed it to our repository's master branch, we would have to specify master right here. Master, and then we can see it's available. And we called it 7sec. And now you see it already in the background pulled the information from the GitHub repo and looked in there what type of components we want to use. So 7sec obviously is the only component we created ourselves, but we could also go in here and use, for example, the max219 driver. which is because we pulled the whole component registry or the complete esphome registry. We can also use all the other esphome sensors, but doesn't make sense to use them from in here. We will just use our custom or our own created component. So, and as you can see, we can specify 7sec in here. I already have everything set up, the multiplexer on the board I talked before, and stuff like that. We have a text sensor where we can pull Home Assistant data from to display on the device. We will use we will create a new display at the platform. We will have 7sec now. It has an ID and the lambda function to display whatever we want. I will just put the hi in here, and I will put a space before it and a space after it, so it's just centered in the middle. For the pins, we can see now that I will just I will just remove them from here. If we would save the component like this, we see E pin is required for display.7sec, and we see we can't create anything like it because there is no pin specified. So we will go and give it an A pin, which if we would be connected to normal GPIO's pin could just be GPIO, I don't know, 0, 1, for example. Whatever. So this would be normal GPIO's pins. B pin, the same thing, the same thing. But because I am connected to a multiplexing hub, okay, this is my access point, I don't care about that. So here, this is my multiplexer, I have specified here. There is a component in esphome I use for this. It has specified data, clock, and latch pins, and it has 3 multiplexer chips in here, and I got all the pins from here. So my pin specification is a little more involved, but you can use GPIOs or every other component that exposes GPIO pins. And for the digits here, you can see I have all my pins set up as well. If those would be GPIO pins, you would just go in here and do it like GPIO 01, GPIO, I don't know, whatever. You can just specify them in here as a list. And yeah, okay, now it says the pin 13 is already used. Let's call it 02. So you see there's already a validation. We can use everything in here we want. Yeah, so we have our functionality covered, and now if we want to test if the component really works the way we want to, at first I would prefer to just install it by manually downloading. This will just compile it, and we will see if the component compiles correctly. Also, while it's compiling, I can say I tested the component in Arduino mode, or with the framework Arduino, and with the ESP IDF framework, and it works with both. So it's not dependent on any specific ESP or Arduino functionality. That may change later because we do have an error. And this is inside our file. So this is exactly why I would just try compiling it before, because we can see, okay, we have an include esphome, no such file or directory. Yeah, because, like I said, we can't include anything from the path of components. So let's have a look in it. 7sec.cpp.1 or line 1. So we will go into the CPP and we see the original file. This is interesting. Why is it like that in the first line this could also come from the header file, I think. Yeah, there it is. I don't know why this import works for the max7219 component, but it clearly doesn't for us here. So, and because we are not dependent on SPI, can just remove this. Obviously, we will have to git commit-am removed unused import, everything passed, git push, maybe just write it the correct way, and if we now recompile, it should work. One thing to mention, in our external component, I specified refresh of 0 seconds. This means that esphome will try to fetch the newest version of this branch every time it downloads. We could also put this to a refresh time of maybe 1 day or something, so it will keep it cached for longer and it won't fetch new versions all the time. Maybe important for you if you have a component you want to work on for longer time and don't get updates for it after maybe a couple of days, or I don't know, whatever. Use it like you want. For development, I will always use refresh 0 because it will always pull the newest version. Also, the ref spec here, like you can see, ref is an optional string, and this is a branch or a tag. So if you have a version you know this that works for you and you want to keep on developing and stuff, and you want all your other deployed esphome devices use the set version, you can also just put a commit hash in here and use a specific commit so they will not update while you work on the repo or whatever. So yeah, like I said, for the testing I use refresh 0 seconds and ref spec of master or whatever branch I'm working on. And if we just now try it again, we see it won't compile that much. Oh, now it's even more red. Okay, I think I won't cut this out because I think having this like closed loop of watching at the output of when the compilation fails and going back to the source code is a very, very crucial point in all the working with this stuff. So I see there is something I did wrong. SPI has not been declared for some reason. Our 7th segment just compiled perfectly right now, but SPI has not been declared for the for one of the multiplexing chips the board uses, which is funny because this config worked for me for the exact same board before. So let's have a look. Okay, this doesn't really help us in any way because it's in a component we haven't created. So we don't. No, I'm completely wrong. I'm sorry. I didn't look deep enough. We see that is in 7sec.c++ line 1. Public SPI. So I think we are still on some branch where there's SPI code left. So let's have a look. Yeah, right here. That's my wrong. I didn't remove any of the SPI imported code up here. So in order to make sure that there is nothing in here that matches SPI, okay, there's nothing SPI in here and nothing SPI related in here anymore. So now we can commit again. Like I said before, claim format now failed. But if we just commit again, everything's fine now and we can push. Now we pushed again. We went in here. We say, please retry the compilation. I forgot to import the vectors. Yeah, so like I said, So we now also have standard vector included. Edit, missing code for vector. Let's see what I forgot now. So again, retry. And this is basically one of the most crucial parts, I think. If you try to develop a component, you will have to rerun it so many times. You could theoretically compile it locally. That's what I did before as well. But I think compiling it on esphome when the codegen runs with the YAML file together, that's very, very important. So we have a redefinition, so this just means I have the same functionality in here twice. CPP, so where is it? Get setup priority. Yeah, it's right below here. Just remove it up here. And again, so yeah, this can be a little bit tedious sometimes, but that's just part of it. Now we can see 7sec has compiled. Everything after this will compile because those are none of the components we have done any changes to. And if it is... So I was wrong again. Did you mean E increment? 7sec does not name a type. 7-segment component. I feel like I had this error before and I didn't know what caused this. This seems to be related to the exporting of the lambda functionality. So let's have a look in there. 7-segment. This is this 7-segment component. This looks to be right. So let's see if the so this is written the same. 7sec component is also written the same here. Let's see. 7sec writer is defined up here, and this is the right definition. Is there the set writer? 7sec writer. This should be all right. Let's have a look at the error again. Main C++ line 24. So, okay. line 24, so this is definitely not in here. So this is a little bit tricky because esphome, obviously, let's runs a code generation step that compiles, or not compiles, but generates a lot of C++ code that gets compiled afterwards. If something in the compilation in between there fails, we get these errors that are, where is it? That are like this. In the main CPP, we don't have the main CPP because we don't create the main file. The code generation generates the main C++ file. So we have a little bit of a problem here, but I think this means that the type, or not the type, but the class the code generation is generating isn't the right namespace. Yes, I think that's the problem. So the namespacing might be, or the namespace might be wrong. So now I clicked it away, but let's have a namespace. This is the namespace, and the namespace in here is 7sec as well. Is it 7sec in here as well? Here it's 7segment, not 7sec. So this was the error. It was trying to generate something with a namespace it didn't know, basically. So let's try it again. Like I said, sometimes it's a little bit tedious. Some of the errors don't really seem to make any sense, but you will have to have a look into it. Same error still. I didn't update the code, obviously. So let's retry it. Yeah, it's a little bit long, this video, but I think for people having those kind of issues, it could be helpful maybe. So I will include everything of it. Because getting a tutorial where someone just copy-pastes it and has an error, or has no error, is, I think it's interesting. You can copy-paste everything else, but if you run into an error, you don't know how to fix it. And here we had some different errors and some different ways to fix them. So maybe you will have the same kinds of errors, and some of those fixes can help you as well. So yeah, this looks good now, I think. It compiles way more. So let's have a look. Best coffee mug in the world. Time to get swifty. Yeah, so it takes some time, but also if all the libraries are compiled with the right build tool once, like with the right platform, like Arduino or ESP-IDF, they will not recompile every time. So yeah, we can see successfully compiled our external component. I could flash it to the board now and show you. And actually, I think I will do exactly this, but I will... I have to do it over the device. So we just connect it. And now I can show you what will happen if we recompile. So it's compiling in the background right now. We don't have any output, and because I'm locally on my instance and not on esphome over HTTPS, I can't use this browser to flash it, but we can use esphome web to connect to the device locally. Also, this is Brave browser for everybody using Brave, which hasn't been enabled for web I/O or web serial by standard. You can just go into your settings or into the flags and set the web serial API to be enabled, which is by default disabled. Just set it to enabled, restart your browser, and web serial will work on your browser. So yeah, that's this. We can now download it, the firmware, to our downloads. There it is. Yeah, it's warning me because it's a binary file, but we can just keep it. We will use this to upload it again and install it. I will have to take the board out of the socket, like I said in the beginning, otherwise it won't compile. Also, this board has a manual boot switch, so I will have to hold the boot button for a time in order for it to boot, and now you see it's erasing. These steps are obviously dependent on your board. Also, I had this board connected to another Wi-Fi previously. That's the reason why I can't OTA update it right now. So I will update it over this once, and then after this I can just update it from in here and go wirelessly. So once this is installed, we can have a view at the logs, and we should be able to see all our output. One thing we can also test is maybe if we are locally connected via serial, maybe we can see the setup log or the log messages inside the setup function when we connect it via serial locally. I haven't tried this, but we can try it together and we will see. So, configuration is installed. Let's have a look at the logs. So, the logs so far don't seem to scroll further, and I think this is because it uses the logs over the logging API from esphome normally and doesn't output them to serial console. So I'll just put the board back into the base. It just restarted. Now it has power, it will boot up. I hope. There it goes. And we can have a look at the logs from within here. So everything connects. And we have connection. When I push the buttons on the board, that hasn't anything to do with what we did. But if I restart the board, we will see that it will push its updating state, I think. Or no, it doesn't. Okay, fine as well. So if you would have done the local install before and you would now update it wirelessly, I will just do this once as well, so you can see how it would typically look if you would be pushing the firmware to the device, and see what it did. So we can see it built the firmware. Now it's OTA uploading it to it over the Wi-Fi. It's already connected over USB, but just for power. And now we see all the log output. And here is the important part. Here we have the log output of the 7 segment. It shows us a pin is pin 0 of the multiplexer, and we have 4 digits which are connected to those pins, the number of digits, the resulting buffer size, the writer is set, and yeah, that's it. So now it displays high on the display. I will also update the config once to display if we use this as ID of home assistant.text .state, and we install this wirelessly. If I then go ahead and open my home assistant. Okay, so this is one very interesting thing. We have no interface for the function to call a normal, or for the print function to be called with a normal standard esphome string, so to speak, or as a C++11 string. And because the state exposes a normal string, there's 2 things we could do. We could do C underscore string. This would expose this as a normal C string, with this, which just is pointed to a char buffer. Or we could, and this is I think what I would actually prefer to do, because this is one of the main use cases for it. We can update the code. We can update the code so far as to include this is the constant, this is the C string, so to speak, and we can just update it to also contain a definition for the standard string, which is just the standard string from the C++, or we could also go into where is the log? Okay, we don't have the log anymore. We could do it like, I think, under C++, something like that. But you can just use the standard string. There it is. And now we have declared an interface for this. I will Copilot being a bitch, Copilot being a pain like all the time. Yeah, sometimes it's not that useful at all. So now we have declared the functionality in the header file, and now we have to implement the functionality as well. I will just use this, and everything we do is just, I would do it inline because it's shorter, but we can also just do it like this for readability reasons. We will just call the normal print for the C strings, and we will convert the standard string into a C string in here. So we can abstract this away from the user. You can do a commit of this, edit standard string print. Now again rerun it because it's just reformatted. Git push, and now we can go ahead, install this again, and now we should be able to just print the standard string. You see it has compiled, and we can go on from here. So I'm gonna open my local Home Assistant. I have entity set up already that is called test. If I now would change the entity, you can also see that it reflects in here. It got the state 1, 2, 3, 4, and you can also see, let me have a look at it. You can also see in here it's representing 1, 2, 3, 4. So we have successfully built a little 7-segment display driver that lets us input data from Home Assistant without an actual hardware or IC driver for the 7-segment display. We built everything as an external component we can just include in everything we want to do. And we could also now set up the pull request for the ESP Home repo in order to merge this into the ESP Home repo so everybody can use it. And I think that's what I will do after I finished work on the component and made it so that it uses the dots correctly and stuff like that. But that's it for now. Thanks for watching. I hope I was able to help some people, and I won't really go into the comments and answer any really any questions, because I think I really don't have time for it. It's just I wanted to push a video out there for people to give them some guidance, but as you saw, I myself am not really too experienced with C++ or the ESP Home build tools, and I just wanted to provide some more frame of reference and some more guidance for everybody searching stuff about this topic, because I didn't find anything or anything too useful at all. And I also asked on Reddit, on the ESP Home subreddit, and one of the devs told me that they are working on a real wiki or a documentation, but it's going very slowly, and it doesn't seem that there is a documentation in a written form too soon, and the only documentation is the source code itself for now. So, like I said, I hope this helped, and hope you liked it. Have fun with it. I really like ESP Home. Great tool, great functionality, very easy to use if you get used to it once. And being able to develop external components, which is the preferred way over custom components, is a very good tool in your toolset, I guess. So have a good day, good luck, and have fun developing stuff.